So the first demonstration that we're going to take a look at today is going to be with regards to assemblies. So there has been a bit of a focus with the 2014 improvements on assemblies. In fact, you'll note that probably about half of the demos that I'm going to be doing in this session are going to be on assemblies. So the first improvement that we have made in 2014 has been with regard to exploded views. So I'm going to create a new exploded view. And I'm going to start, we'll pick up these two nuts here. And the big change that we've got in 2014 is the ability not just to translate components, but you notice we also get these rings around here as well that we can use to rotate the components as well. I'm going to continue, we'll bring these bolts out here. Now with this, the actuator here, or the cylinder, I want to rotate it, so I want to show that it needs to be rotated before it can then be raised up. So I'm going to rotate it. One of my favorite improvements to 2014 in this particular area is the fact that you no longer need to hold down the Alt key when you reposition the triad for your exploded view. So most of you should remember that in order to reposition the triad in 2013 and previously, you had to hold down the Alt key. There's no real reason for that, so it's been eliminated in 2014. So I can just grab the center of the triad here and reposition it over to here, and you can see we now have the ability to rotate this component about that position. I'm then going to add a translation as well. So now when I close that, we'll go to the explode view here and animate the collapse. So you can see it brings down, we've got our rotation as well as our translation in our explode view. So really good for things like service manuals and things like that, where you want to be able to show the rotation of components as well as the explode. Just the same as yesterday, any questions that we've got, I'll save to the end, and I'll make sure I go through that, the question list at the end. All right, another improvement that we've got to 2014, and again in this focus of little things to try and improve the user interface, has to do with the access of configurations. So if I select this part here, you can see I've actually got access to the configurations directly from that flyout tree there. If I want to change the configuration of the subassembly, I just need to make sure I select the subassembly first, and then you can see I've got access to my configurations here. So if I switch, for example, to the retracted configuration, hit the tick, it changes that subassembly very quickly to the retracted configuration. I've got another configuration here of the subassembly called free, but I am unable to move this because at the moment this subassembly is not actually flexible. Everything that we've been doing here is also available in the flyout feature manager tree. So if I select the subassembly here, you can see I've got access to the configurations. What I need to do though is switch this to flexible. And most of you will remember previously the only way to access to switch between flexible and rigid was to go through the properties. This has been improved greatly in 2014 because we have access, if I select the subassembly, to make subassembly flexible as a button here, or if I select the subassembly here, right there. So I'm able to switch between solve as rigid and solve as flexible without having to go into the subassembly's properties. All right. Another improvement to assemblies in 2014 has been with regards to mirroring. So if we take a look at the mirrors here, the mirror component feature here, I've actually got a document that shows the new mates that are available in 2014. So these mates are not new mates in the traditional sense. These mates are now available to be used as part of the mirror. So cam mates, hinge mates, linear coupler, path mates, symmetric mates, universal joints and width mates are all available to be mirrored when you mirror components inside your assembly. However, there has been a bit of an issue if you've got asymmetric sub-assemblies like this scissor that we've got here. So I'm going to go back up to this scissor assembly and unsuppress a component. So you can see at the moment we've got this mirrored correctly to the other side. But if I unsuppress this extra component on this side here, because the center of mass moves, the mirror is now incorrect. We can see it's not lining up correctly with these bolts. So what I'm going to do is go into the mirror feature and to step 2, and you see there's an option here now to change the mirror type from center of mass, which is how it's been set at the moment, to a bounding box center, so like a geometric center. So if I change that to bounding box center, we can see it now correctly aligns the mirrored components and get what we're looking for. All right, advanced selection tools. These are some of the tools that really make the difference between a competent SolidWorks user and an advanced SolidWorks user. Most of you may not be aware of all of these options that we've got when it comes to selecting components in an assembly. Most of these are not new for 2014. So for example, I can select all of my suppressed components or select all of my hidden components. I can pick a component and then select everything that is currently mated to that component. So everything that's got a mate to that component that I did have selected then gets selected. The new one for 2014, however, is this select by size. So what this allows us to do is to specify a size with respect to the overall assembly, and it selects everything that is smaller than that size. So if I say anything that is 6%, 6% or less in terms of the volume of the component with respect to the volume of the assembly, hit OK, and now I've got all of those smaller components selected. So it makes it nice and easy to suppress those small components if you need to create a simplified configuration of your assembly. All right. One of the features that was introduced in 2013, was scroll selected item into view. So if I select this component here, it scrolls down and highlights the selected component. The problem that we had in 2013 with that was that if you had a very long feature manager tree like I've got here, selecting a component would move where you were looking previously in your feature manager tree, and you could very easily spend a lot of time having to scroll back to where you were. In 2014, we've introduced the feature that now, if I am wherever I happen to be in the feature manager tree, so if I'm right at the top here in my feature manager tree, if I select my component, it scrolls me to the location of that component. But the improvement in 2014 is if I then deselect that component by selecting the background, it takes me back to where I was, in this case at the top. If I scroll all the way to the bottom and select that component again, it scrolls me to where that component is, but then when I deselect, it takes me back to where I was. So it makes it just a lot easier to navigate that, the larger feature manager trees to be able to find what you're looking for. All right, Assembly Expert. This is another one of these tools that I find a lot of people don't take a lot of, or as much use of as they should. So the improvements in 2014, first of all, is that the report showing the rebuild time now reports it in seconds rather than milliseconds, so we can get an idea of the full rebuild time of the assembly and what's contributing to that rebuild time. If I switch back to the Assembly Expert, we now list off the total number of hidden, virtual, and envelope components, in addition to things like your suppressed and fully resolved and lightweight components. But my favorite improvement here, especially those of you who have ever done any training with me would remember me harping on about making your assemblies as deep as possible rather than flat, is that we now not just report the total number of evaluated mates, but that we split it up between the top-level mates and sub-assembly mates. So this gives you a good idea of the effect of making your sub-assemblies flexible has on your overall assembly, and also a good idea of how many top-level mates you've got. Because obviously the downside of making your sub-assemblies flexible is that SolidWorks must rebuild all of the mates in that sub-assembly in order to understand how that component moves. And so previously we've never been able to report how many flexible sub-assembly mates are actually being rebuilt in the assembly. But as of 2014, we do have that listed there. So we've got the number of top-level mates and the number of flexible sub-assembly mates. Finally, we have the ability to report. The View Mates tool works not just on parts, but also on features. So for example, if I hide this component here and I bring up this part here, I can actually expand the part out, pick on a feature, and have a look at all the mates that use any faces generated by that particular feature. So obviously not a great example there, unfortunately. So let's see if I've got another one here. I might luck out. There we go. So we can see that this feature creates faces that are being used by these two mates. So again, as I was bringing up yesterday, as I brought up yesterday, it allows us to get ahead of our problems. So let's say I wanted to make a change to this cut. Maybe I wanted to eliminate this cut. I can find out very quickly if this is going to affect my top-level assembly in terms of mates. Are any of my mates going to fall over if I suppress or delete this feature? Because we can now use the View Mates functionality on features rather than just parts. The next thing that we're going to take a look at are assembly patterns. So there's been a few new assembly patterns introduced in 2014. So first of all, so that the three new patterns are if I go to the assembly here, patterns, so the three new ones are the pattern-driven component pattern, the sketch-driven component pattern, and the curve-driven component pattern. Obviously, sketch-driven and curve-driven patterns have been available to us in parts for quite some time. However, they have not been available for the at the assembly level. So let's take a look at a couple of those. So the first thing that I'm going to do is to create a pattern using this sketch. So this sketch at the assembly level is used to define some of the other patterns, and I'm going to use it to pattern the missing links that we've got here. So under patterns, I'm going to use my curve-driven pattern. The curve is that sketch 2. Space, so total number is 24. And we've got 9-inch spacing between them. And I'll pick the components to pattern. Looks okay up here, but as we come around the corner here, we can see we've obviously got some settings wrong. So first of all, I want to switch to offset curve, and the alignment, we want the component to stay tangent to the curve as it curves around. So that's what we've got there. That's looking pretty good. Hit the tick. So the advantage here is that we can obviously modify this sketch, this curve, and it will modify the curve-driven assembly patterns that we've got created from it. The last one that I'm going to do in this example here is the pattern-driven component pattern. So this allows me to pick up an existing pattern. So my assembly, pick up an existing pattern, and all of the settings for that pattern are repeated in this assembly pattern, just like it would be in the as it would be at part level. We also have the ability to specify instances to skip if we don't want to use every instance, just like before. Hit the tick, and it applies that pattern for us. My favorite improvement, though, with regards to patterns in 2014 actually has nothing to do with what we've seen so far. It's a very simple improvement, and that's the fact that if I select a pattern, the seed components are shown in a different color. So you can see the seed components here are pink, whereas the instances are in blue. So we can actually very easily see which components are the seed components just by picking the pattern. Also, if you hover over any pattern, it will give you the basic information about that pattern. So the type, the seeds, the direction, the type, the spacing, and things like that. The next pattern improvement is a nice simple one, and it's to do with multi-bodied patterns. We've had the ability to pattern bodies for a long time. The improvement that we've got here is in circular patterns. If I edit this and increase the total number of patterns of this cut to the point where it's now creating these multiple bodies, we now have the ability to decide which bodies we want to keep. Previously, all bodies would have been kept. So we now have, the ability to select which bodies we want to select if the result of a circular pattern of bodies, or circular pattern of a cut results in multiple bodies. So a small improvement probably won't affect most people, but for those that will, there's a nice little improvement there. All right, now we're going to get into the flashy stuff. So what we've got here is some improvements to mates in assemblies. So we've sped up the ability to add mates, and there's actually been one improvement that I know people have been asking for many, many years. I'm talking 10 plus years now, and we'll see that in a moment. But to begin with, I want to show you an improvement to smart mates. So I'm going to use the alt drag technique to apply a mate between this cover here, this guard, and the hole that I want to apply it to. So hold down Alt and drag, and what you'll notice is that there's now a delay between when I hover over the face or edge and when it attempts to apply the mate. The reason for this is we now have the ability to specify whether to attempt to apply the smart mate immediately or whether to delay. So what it means is I can move over these holes without it jumping around like a crazy thing, and then hover over the actual face that I want to apply the mate to, and then drop it down. This is actually set under options, and I don't actually know where it is, so I'm going to use the search tool introduced in 2013 to find Smart Mate, and here it is, Smart Mate Sensitivity. We can see here you can use this slider to set it off, which is where it basically will mimic the functionality in 2013 and previously, and then you can set the delay from fast right down to slow, which is where I've got it set at the moment. All right, I'm now going to use some functionality to apply a smart mate that a lot of people may not actually be aware of. And that is on the assembly toolbar in the Move Component tool, we have the Smart Mates button. Now I have to admit I've been using SolidWorks for far longer than I'm willing to admit, since 1997, 98, and I was not aware of this until I actually saw this demo. So if you click on this SmartMates button here, it changes the name of the command to SmartMates and allows you to apply mates by double-clicking on one face and then single-clicking on another face. And it applies it. And it applies it just like as if you use the Alt-Drag technique. So it brings up the dialog very quickly. So the improvement here in 2014 is this lock rotation option. So if I click on lock rotation, it's going to prevent any rotation between these two components about the axis of the concentric mate. It doesn't matter how you apply the concentric mate, this will be an option for all concentric mates in 2014. So what this allows you to do is to prevent that rotation with the component without adding the overhead of applying an extra mate for each cylindric or for each concentric mate. So a huge improvement in my opinion in 2014. One of the advantages of using this SmartMates dialog box rather than the Alt-Drag technique is that you can actually rotate in between your selections. So I can rotate around to here, double-click on this back face, rotate back around, and single-click on this face here to apply that mate between the two components. But let's say I want to use that SmartMates functionality. I'm going to pick a toolbar here that doesn't have too much on it, and if I search for the command SmartMate, it now has its own button. What that means, I can drag this command from the search results, the command search results, drop it onto a toolbar, and you can see I've been practicing because I've already got a copy of it here. So we can drag that command onto any toolbar in SolidWorks, and I can now click on that and double-click on one face, single-click on second face, and apply it, lock the rotation, hit OK, rotate around, double-click on this face here, rotate back around, single-click on this face, and we'll apply that concentric mate. All right, pretty good stuff so far. Now, there's some small improvements here that I believe a lot of you are going to appreciate. If I was to apply a mate between two edges, the default type in 2013 and previous, in fact, the default type even in 2014 is coincident or collinear, to make those two edges lie on top of one another. The problem with that is that it would over-define the assembly. We can't actually make those two edges because of the other mates we've applied. We cannot actually make those two edges coincident to one another. What happens in 2014, however, if I hit mate, if the default mate type would over-define the assembly, it automatically defaults to the next available mate type. So it's gone from coincident to parallel without bringing up that over-defined dialog box, forcing you to click through it and then pick the parallel mate. Hit the tick, and that mate's now been applied. In the same vein, if I apply a mate now between an axis and a cylindrical face like this, and I hit mate, the default mate type is now concentric, not tangent as it was previously. So that just makes a lot more sense. All right, but the big improvement in 2014 has to be quick mates. I now have an even faster way of applying mates between these two faces here. If I select the first face, Control select the second face and let go of Control, notice that underneath my left click menu here, I now have a row of quick mates. I can click on concentric, it applies the mate and doesn't even bring up a dialog box. Much, much faster. So I want to apply a mate between, say, this face here and this face here, let go, apply the concentric mate, and it's done. This face here, coincident, and it's done. I'm going to keep going, so apply mate between this face and this face here, and these two here. In fact, if the default mate type is the one you want to apply, you don't even need to move your mouse away from there. You just need to hit enter. So I've clicked those two faces, I press enter, and it applies the default mate type between the two. Now, you will, or some of you may realize that it hasn't actually locked the rotation on that concentric mate. In order to do that, I'm just going to bring up my view mates, right click on the concentric mate, and we can lock it. And then close the view mates dialog box, and that's now been locked down. All right, next demonstration we've got is spherical mates. All right, so in 2013 and previous, we've got lots of ways that we can mate spheres. We can mate them to one another, we can mate them tangent to planar surfaces, tangent to other spherical surfaces, tangent to cylindrical or conical surfaces, and we can make them concentric to spherical surfaces as well. In 2014, we have a big improvement to the types of geometry that we can apply mates to. So I can apply a mate now between this elliptical edge here and my sphere. I can apply a tangent mate. I can also make my sphere tangent to this surface, which is a loft between a partial ellipse and a conic. So remember conics from yesterday? Tangent, I can apply that mate there. I've got this toroidal shape here, tangent to that, and this spool shape as well. I'm going to go tangent to that. And finally, I can even be tangent to this 3D spline that I've got here as well. So apply a mate. The default mate type is tangent. So it will move, staying tangent to that 3D spline. So a lot more options when it comes to applying mates with spheres in 2014. The last example that I've got here is to do with slots. We have slots are obviously we have better support for slots in 2014 with respect to them now being in Toolbox. The support that we've got for them has been improved to the point now where we also have the ability to create a new mate type called the slot mate. So if I apply mates, mechanical mates, slot, I can now select any cylindrical face and any face of the slot, and we can apply our slot mate. By default, the constraint is free, so that allows it to move from one end of the slot to the other. If I edit that mate, we also can mate it to be centered in the slot. So this is really handy if you've slotted the holes that you want to put your bolts through, but you just want to show the bolts centered in that for clarity. You also have the ability to specify a distance along the slot or a percentage distance along the slot. And you can flip that from one end to the other. We can also apply slot mates between holes. And in fact, we can even apply them between non-cylindrical entities by using an axis that you want to align in the slot. So I select the axis and the face, apply a mate, mechanical slot, and it will move that component within the slot. What you will notice is that it is allowing some interference at the points here. What it's essentially doing here is allowing the axis to move along the sort of axis plane, I guess you could say, of the slot itself. So in terms of sizing, it's not performing any interference detection or anything like that. It's allowing the axis of the hole or cylinder or the axis itself that you select to move along the center, the distance, I guess, between the two center lines of the slot. We also have the ability to apply mates between two slots. So I can actually pick two faces of slots like this, mechanical mate slot, and it will allow the free component to move in the full range of motion that we have available between the two slots. I reckon that's pretty cool. The slots don't even need to be on a planar surface, so we've got a slot here that's been cut into a cylindrical surface. That works there. And we've also got mates between two arc slots as well, two center line slots, or center mark slots. Slots that do not work include slots that don't have cylindrical edges, ones that only have one cylindrical edge, so it must have two, slots that break the edge of the part, slots that don't have parallel faces, and also slots that curve, as you see here. So at the moment they must be either concentric or linear. All right, let's now take a look at some visualization. So the first thing a lot of you, so from the poll that I ran yesterday, about half of you have already upgraded to 2014. And one of the first things that you may have noticed is the user interface has changed a little bit. It's been cleaned up, but the most important aspect, I guess, from in my opinion, has been there's been a color change. So a lot of the icons sort of had this yellow-green that we see here for the assembly symbol. They've been changed to this blue-yellow rather than green-yellow. The reason for that is that yellow-green is actually a horrible color distinction to make for people who have certain kinds of color blindness. So the user interface has been changed throughout to use this blue-yellow rather than yellow-green color for a lot of the selections available in the property pages. All right. Last year in 2013, we introduced a favorites folder that allowed you to favorite the most common features or parts in your assembly or part and have them appear up the top. I'm going to edit my pressure plate here. And you notice in here there is a history folder. In fact, for all assemblies and all parts, by default, you have this history folder. And what it shows you is the 4 or 5 last features that you have edited. You can edit this by right-clicking on the history folder and selecting History Options, and then selecting the number of items that you want to show in your history folder. This access that you have to these features in the history folder is identical to the access if you actually expanded it out and found the feature that you're actually, looking for. So we can select it, edit the feature, make changes to our dimensions, rebuild it, and it will bring the last feature that you edited to the top of the history tree. So if I now go to this sketch and edit the sketch and make a change there, close the sketch, it moves the sketch to the top of the history tree. So a lot handier, I guess, than having to manually select your favorites. The favorite folder is still available, but we now have this extra option of the history folder to be able to display the top X features that you've edited. All right, I'm going to switch back to the top level assembly now. and show you the new options that we've got with the Save As dialog box. So we now have 3 options when we use Save As in SolidWorks. We have Save As, which is our traditional Save As method. So it saves it to a new name. Any documents open, i.e. assemblies or drawings, that reference this document will have their references updated to point to the new document. Save as copy and continue is, we'll save the file to a new name, does not update the references, but leaves whatever you currently have open as the file that is still active, I guess, open in SolidWorks. The new one is save as copy and open. So save as copy and open does what it says on the tin. It will save a copy to a new file name. It will not update any other files that you currently have open, and it will then open that new document and allow you to start editing it. So what this option does here is, I guess, it gives you the ability to work a little bit like the Save As and a little bit like the old Save As copy, in that it does save a copy without updating the references, but it shows you that component on your screen. So I guess most of us have been through the school of hard knocks in terms of making mistakes with regards to these options and editing components that we didn't really want to be editing. The idea is, hopefully, is that as these options have become clearer, fewer people will make those mistakes. The new option that we have here too with Save As is this include all referenced components. So this is a little bit like our, I've forgotten the name now, I'm going to have to go back and have a look at it, the Pack and Go. That's the one I'm looking for. So when you use Save As, we can now pack out all of the referenced components, adding either a prefix or a suffix, or using the advanced option to rename the files individually, and then you can save out the assembly and all of its referenced components in one go. All right. SolidWorks 2014 has introduced a new visualization tool that changes the way we show transparent components. So you'll notice in 2014 it takes advantage of newer graphics card technology, especially where you've got multiple overlapping transparent components. They'll look a lot clearer, a lot less muddied than they have previously. Switch back to the full display. The next example that we're going to take a look at is, or the last one for assemblies actually, is the section tool. We've had a few improvements with regard to the section tool. One of them, again, has been one's been requested for a very long time. So when I click on the section tool now, I'm going to switch to the top plane as my cutting tool. But we now have the ability to specify which components we want to section by using this selected components option. I can now exclude selected or include selected. So if I say include selected, I'll then pick the components that I want to section, and we can get a nice sort of cutaway. So we're only sectioning these components here. So we can do one of these sort of nice cutaways that we've all seen sort of in engineering school, where we see gearboxes and things like transmissions and things cut away. So one of my favorite improvements to the section tool. The other improvement to the section tool, if I don't use selected components and I do want to section absolutely everything, if I was to section everything like this, I hit the tick and count, so it's sort of 1, 2, 3, 4, 5. So about 4.5, 5 seconds on my computer to section through all of these components. If I go back and section it again, we have a new option in 2014 with this graphics only section. So if I use the graphics only section, hit the tick, and it's done. So it's using the same technology that it uses to preview your section to actually display the section. So it takes no time at all to actually perform this section. There are some downsides to it. The first is that you can't pick any of the sectioned faces. So it's literally just graphics only. So if I try to pick this face here, it's actually picking the face behind it. I can't actually pick any of these section faces. The second is that we cannot display this in drawings at the moment. But if you need a section view for visualization purposes, this graphics only section is going to save you a huge amount of time, particularly when you section through a lot of components like I have here. All right, guys, we'll move on now to simulation. I'll close that one too. All right. My favorite improvement to simulation in 2014 has to do with bolted connectors. If you use Toolbox to apply your fasteners in SolidWorks 2014, when you create a new simulation study, you will have the option to convert Toolbox fasteners to bolted connectors. It does say may take time. What it really should say is takes much less time than actually creating the bolted connectors manually. So I'm going to hit the tick, hit OK, and so it said it's picked up 2 simulation bolt connectors, and what we find is if I go into this new simulation, it's already coming with 2 bolted connectors. And if I edit the definition on them, we can see it's automatically picked up their locations, so the edges, the geometry, the material that the fastener was made from, including its strength data, and even a recommended preload for the fastener as well. So for those of you who need to do analyses of large assemblies with lots of bolts through it, it's going to save you a huge amount of time to be able to reuse your Toolbox fasteners as bolted connectors in Simulation 2014. The interface has also been improved in Simulation 2014. So if I bring up a stress plot here, I can right-click on the legend now and do things like changing the stress components. So I was using von Mises stress. I can change this to, say, first principle stress just by right-clicking on the legend. I'll switch that back to von Mises stress. Maybe I want to change the fringe option to discrete. So I can change it from continuous to discrete, and maybe I want to show the mesh as well. So I can very easily see that a lot of my results is being influenced by the mesh. So just through right-click options available to us here, we're able to toggle things like the mesh, changing the fringe options, and also the stress components that are being displayed here. By left-clicking at the top or bottom of any legend, I can change the maximum and minimum displayed here. So I can change the minimum to any value that I want. If I want to bring it back to the true minimum, to automatic, I can just click on this button here and it resets it. Same with the top, I can reset that to automatic as well. So some improvements to the way that works, but my favorite is the fact that edit definition, chart options, and settings are now all kept in the one tabbed interface. So if, like me, even after 8 years of teaching simulation, I still forget where each of these options are in terms of definition, chart options, and settings, we now don't have to be sort of opening and closing each of these options to find it. We can just flick through the tabs to find the option that we're looking for. So in my opinion, a huge improvement to SolidWorks simulation. All right, some more improvements to simulation. We can now, in Nonlinear Studies, we now have the ability to show contact pressure. So I now have the ability to display contact pressure in 2D simplification plots in Nonlinear Studies. So we can see there the contact visualization of these two gears as they mesh at this point here. So this was not available to us in previous releases. We also have access to a new materials database. So if I select my apply material, there's a link here that says click here to access more materials using the SolidWorks Materials web portal. This links to a website called Materiality that allows you to search a huge list. In particular, SolidWorks simulation does not have a huge amount of nonlinear material models. Materiality has a huge number of material models for nonlinear studies, nonlinear materials. So you can use this to search for, find your materials, and then import the material directly into SolidWorks by clicking. So basically you save an SLD MAT file, then click on Open, browse to where the SLD MAT file is, and it then gets added to your custom materials in SolidWorks simulation. Find the right one, there we go. Alright, another one of my favorite improvements to simulation in 2014 is the ability to define symmetry plots. So if I bring up the, sorry, not simulation plot, the contact visualization plot, getting ahead of myself here. So if I right click on the connections, select contact visualization plot, it's going to show for me, once I hit calculate, all of the contacts that have been created either manually or automatically by the mesher. So we can see straight away here we've got a problem because we do not have a bonded contact between the back face of this plate and the front face of this plate because it hasn't turned red. The different types, so no penetration contacts show up in a different color from your bonded contacts. This is a great visualization tool to be able to understand why your model may not be restrained correctly. Looking at this stress plot, we may understand as design engineers that we've only analysed half of this bracket in order to save time because it's symmetrical. But in order to communicate these results effectively to maybe non-technical people, we now have the ability, if we edit the definition and go into advanced options, we now have the ability to display symmetric results. So if I check that and hit the tick, it will display the complete model with the results being mirrored across to the other side here. So very handy if you've got non-technical people trying to understand the results that you're displaying in symmetric results. Now the final bit of simulation that I want to show you is a bit of results comparison. One of the big advantages to using a tool like SolidWorks simulation is the ability to compare different designs. So I've got three different options here. I've got the plate one that we just saw, one with a big hole in the plate here, and a third option with these slots cut through it. We now have the ability to compare the simulation results across all of these options. So all I need to do is right click on the plot, compare results, and I now have the ability to compare results across all studies in all configurations. Previously we could compare across multiple studies, but only with the one configuration. So hit the tick, and we can now see a comparison of the stress plots across all three configurations. Finally, we have a new solver in 2014. If I go to my simulation options, we now have, make sure I get the, result loading, not different one. We now have the ability to show or to decide whether we want to load all simulation studies when you open a model if you've got simulation open. So what this means is you can keep the simulation add-in turned on without it automatically loading all the simulation studies every time you open an assembly or a part that has a study. By unchecking it, all that it requires is that you would need to load the study when you first switch to your simulation study. So rather than having to toggle SolidWorks simulation off and on, you can leave it turned on and only load the studies when you actually want to display them. What I was trying to get to before is actually a property of the study, and that's the fact that we have a new solver called the Large Problem Direct Sparse Solver. So this has been designed to work best with large problems, I believe in the 5 to 10 million degrees of freedom, but don't quote me on that. And it also utilizes multiple cores much better than FFE Plus once you get into that sort of range. Selecting automatic as your solver will choose the best of the three in most cases. Alright guys, the last demonstration that I've got before we get into a bit of a Q&A session is to do with appearances. So the first thing I want to show you, if we do a save as, we now have the ability to save out our part as a PNG file. And if I select options, what that allows us to do, if we switch from screen capture to print capture, is to set the DPI for this PNG. So previously we could only choose bitmaps, and they tended to come out a bit chunky because they would be displayed in the resolution of your screen. So now if you choose PNG and hit options, you can switch from screen capture to print capture and then choose your size, maybe A4, and then the DPI to get the resolution as high as you want. And that is without having to have PhotoView 360 added in. With PhotoView 360 added in, however, you now have the ability to save out your model as a Luxology scene. Luxology is a high-end rendering tool from the same company that produced PhotoView 360. So if you do have Luxology, you now have the ability to export out your lighting and cameras from SolidWorks PhotoView 360 into Luxology. All right, a few more options that we've got available to us. Your scenes that you've got here. Most of us would remember from 2013, if you click this drop-down list, you would get a huge list of scenes to choose from. We now have this Manage Favorite option that allows us to select which ones we want to have displayed in that list. So now, if I pick my drop-down here, it only shows those ones that I've got favorited. So I'm going to pick one of those. I've also got a pre-selected view that kind of looks good in this scene. If I switch out to my scene now, so the last tab that I've got here, and edit the scene, I'm going to stretch the image to fit whatever resolution screen I've got. So we can now see, if I just collapse that down, it's stretched the image out to fit whatever aspect ratio my screen is. Alright, I'm now going to play around with some other settings within Edit Scene. I'm going to use an environment map now and choose to flatten the floor. So it basically creates it like a giant cylinder. I'm going to set my environment size to 35 meters. That's starting to look pretty good, and I can change the horizon height as well. So I'll set that down to about 0.24, 0.25. So all of these things allow us to make our model look less odd in the screen. So all of the things that I've done so far have been available to us without having to use PhotoView 360. The last little bit that we're going to look at does require PhotoView 360. So if I go to my Render Tools options, we now have some new options for contour rendering. If I click on this contour/cartoon rendering, we've got some new options. So contour used to be the only type of contour rendering that we could do. We now have the ability to also use cartoon rendering. And I'll give you a bit of a look at how this, what this actually looks like. So here, so this is our standard render with the background removed, and this is what our cartoon rendering looks like. So we get thicker edges, and the shading looks a lot more defined. So it's not trying to look as realistic, and it can be much more effective sometimes if you're not trying to get photorealistic rendering. All right, the very last demonstration that I'm going to do is to do with sunlight. So we now have the ability to add sunlight. So under Scenes and Scenes Lighting, right-click on Lights, Add Sunlight. We specify where we are on the planet. So the closest we've got here is, to me anyway, is Sydney. But if you know your longitude and latitude, you can specify your location. And it sets the lighting for that location. So the sunlight, and you also specify the date and also time. What this then allows us to do is to go into a motion study, use the animation wizard, solar access study, and we can now do two different types of solar access study. One is fixed date variable time. So I could say today from sunrise to sunset, I want to see how this renders. The other option we have is fixed time variable date. That allows us to say, okay, at noon from June through to December, what is the noon sun going to look like? So picking either of those, we then specify, okay, I'm going to say sunrise to sunset, next, finish, and it will automatically create the movement of that sunlight across the time frame that you had set. So I've got one that I've previously rendered here that I'll show. So you can see there the shadows and the lighting moving across as we go from sunrise to sunset. All right, guys, that brings me through to the end of the presentation. Thank you very much for your attention over the last day or so. What I'm going to do now is open up for questions. So I'm going to take questions from the question box here. I'm just going to remove some of the ones that aren't related. I'm going to start to answer questions. So if you've got any questions that you'd like, feel free to add them to the Q&A session. Otherwise, if you must head off immediately, thank you very much for your time. These webinars will be available for download from the Intercad website. We need to give Vernon a couple of days to edit them and get them up onto the website. But if you, I'd say middle of next week, if they're still not available, you can email info@intercad.com.au to question Vernon about where those the webinars are. So I'm now going to jump into some of these questions. Yep, so a lot of them. Okay, so the how many rings, I'm assuming, is to do with the rotation. So there are 3 rotation rings during the exploded view about each axis. The reason only 1 ring was displayed was because I'd already translated the first component, so the rotation ring available is only the rotation about the axis that I had already translated that component. Why should the assembly be deep and not flat? The main reason for that, Richard, is because SolidWorks only needs to resolve mates at the top level assembly, not at the sub-assemblies. So by having a very deep assembly and having few components at the top level, you will have fewer mates to resolve at the top level, and you'll have a faster performing assembly. Okay, the demo assembly that I was using is a very odd looking thing. It's actually like a tracked scooter. If you'd come at the presentations, we actually showed a few videos at the beginning before we started. It's basically a motorized tracked scooter that you can use to, so it's got a motorbike engine attached, or possibly a snowmobile engine attached to it, and you basically stand on top of it and it sort of scoots across dirt. They can do jumps and stuff off it. It's a very cool looking device. More about when it will go up. Yeah, I could use select other rather than rotating the view. The main reason was I just wanted to show the fact that you can rotate in between the selection of the components. Okay, save as with references is identical to pack and go, except that you do have the ability to save them without updating any references. So if you had an assembly being referenced by an open drawing, you can use save as with references without having to update the drawing, I guess is the only difference. Can graphics only sections be rendered? I don't know, to be honest. I would have to check that. I don't actually know the answer to that question. Yep, the presentations are available. Somebody's just out of interest how many people were watching. So yesterday's one maxed out at about 150 of you. Today's was a little bit short of that, I think maybe 120 or so.